Thanks for checking out another new AMP podcast. I'm your host, Ben Dubose, and I'm the news editor with the AMP publications team. AMP, of course, is the shorthand acronym for the Association for Materials Protection and Performance, which earlier this year turned 5 years old. AMP is a combination of two legacy organizations, NACE International and SSPC, the Society for Protective Coatings, and obviously their legacies extend out many decades. Anyway, as part of the 5th anniversary here at AMP, we've got our ongoing Then and Now Thought Leadership series, which we've been doing with interviews throughout this year on this podcast channel, as well as through our various print and digital platforms. The idea in these conversations is to bring together experts from around the world to discuss where our industry has been, where it is today, and where it's headed next. For today, our conversation is focused on a topic that influences nearly every decision made in corrosion prevention and asset protection, and that's standards. Industry standards are built from decades of research, field experience, lessons learned, and collaboration across industries and continents. But how do they evolve? Who shapes them? And how do we ensure that they remain relevant as technology and industry needs continue to change and evolve? To discuss that, we've got a group of 2026 AMP ambassadors with us today whose work spans industry, academia, research, training, and standards development. Will each of you please introduce yourselves to the audience? Just begin by telling us your full name, your employer, and where it is in the world that you're based. Raghu, we can start with you.
Hi, everyone. Thanks, Ben, for the introduction. My name is Raghu Srinivasan. I'm a professor and chair of the Mechanical Engineering Department at the University of Alaska-Anchorage. So obviously, I'm joining from Anchorage, Alaska. My research focuses primarily on atmospheric corrosion and the performances of materials in cold and subarctic environment. I kind of do laboratory research with real-world infrastructure challenges that includes transportation systems, pipelines, assets that are exposed to Alaska's unique climate. My involvement with AMP, I involve through research, technical activities, student engagement. I'm currently the chair for the Research Society Leadership Council, and I'm also one of the 2026 AMP ambassadors, as Ben mentioned before. So I'm looking forward to this conversation. Thanks, Ben.
Absolutely. Thanks for joining us. George, over to you.
Thank you, Ben. It's a pleasure to be here. My name is George Joseph, and I am joining from Saudi Arabia. I work as a senior inspection specialist in Saudi Aramco Project Inspection Department, mainly in the area of corrosion protection, protective coatings, welding, pipeline, and asset integrity. My role involves making sure that engineering standards are properly applied during fabrication, construction, testing, and final inspection. I have also contributed to the review of development standard, inspection procedures, technical guidance, and I have participated in international AMP standard setting activities. I am also proud to be served as AMP Global Ambassador representing Saudi Arabia, and I am very pleased to join this discussion today. Thank you, Ben.
And finally, over to Washington.
Yeah, good morning, Ben, and thank you for the opportunity to join this discussion. My name is Washington Nyoni. I'm a senior corrosion engineer and cathodic protection specialist with Corrosion Control Engineering based in Melbourne in Australia. I've worked in the corrosion industry across different regions in Africa, the Middle East, and Australia. This has exposed me to a wide range of environmental conditions, infrastructure type, and corrosion challenges. My current work is mainly focused on cathodic protection, corrosion assessment, and asset integrity management for major water utilities. I'm also involved in the technical training and corrosion research, and also an AMP instructor. I'm very pleased to join my fellow ambassadors for today's discussion. Thank you.
And with that, let's dive in. As a disclaimer off the top, some of these questions are going to be specific to one person, while others are designed to have multiple responses from the panel at large. Let's begin by exploring why standards matter in the first place. George, you've been directly involved in the development of all sorts of standards and technical guidance. What are some of the things that professionals misunderstand about how these standards are actually created?
That's a very good question, Ben. I think the biggest misunderstanding is that standards are created only by a small group of experts. They are sitting in a meeting room and deciding what industry should follow. In reality, a good standard is developed from many sources: research, field experience, failure investigations, operational lessons, and new technology, manufacturing book, and feedback from inspector and the end user. From an inspection perspective, a requirement cannot remain only theoretical. It must be practical, measurable, and variable in the in the field. For every requirement, we must need to ask can the contractor implement it correctly? Can the inspector can verify the complaints, or are the acceptance criteria very clear? And can the result be properly documented? Another misunderstanding is the standards are fixed forever. Standard must continue to evolve materials, technologies, inspection methods, and operation conditions changes like that. However, any revision must be supported by technical evidence and proper field verifications. I believe so. So I would say standards are not as simply written documents. They are the combined experience and lesson learned of industry converted into clear and enforceable requirements, as per my opinion.
So turning to the group, when the two of you think about the standards that you use today, what has the biggest influence on the way those standards have evolved? Is it research? Is it failures? Is it operational experience? Technological advancement? Speak to what you see as the biggest influencers on standards and their evolution. Raghu, we can begin with you.
So for me, all four components are really important. Okay, it's the combination, the synergy between research. Sometimes research tells you what the scientific mechanism is, but when we take it to the field, not necessarily it's going to work, and there are other variables, other factors that actually influences that. And the other thing is like some of the standards probably would have been approved a long time ago, and as time evolved, the technologies have changed. So now we need to adapt to the new technology in terms of like how we can see the standard in a different perspective. So I understand where standards are coming from. So they want it to be consistent. It doesn't matter where you perform it, who performs it. The standard needs to have that underlying consistent performance, but not everywhere is the same place. The technology is changing. So from my perspective, when I'm doing research, I have that flexibility of moving slightly away from the standard and see how things work, and then coming back to the standard and say, yes, it works. No, it's not working. And now we have to go back to the table, bring the groups together and start thinking about like how we can evolve the standards. And most standards, you can see there is that the 1.0 version, 2.0 version, and as it keeps going. And obviously, like with standards, they put the years in it because they know like it's the same standard, and then it kind of like got evolved over a period of time.
And Washington, over to you. What do you see as having the biggest influence on how standards evolve?
Yeah, I think I believe I agree with what Rahul was saying. All the four factors play a role. However, operational experience and failure often create the strongest pressure for standard change. So research provides the scientific foundation. It helps understand corrosion mechanism and develop new standard of prevention monitoring. Operational experience then follows whether those methods are practical and effective under real field conditions. So failures are particularly important because they expose weakness in design, construction, or maintenance practices. And one thing to add also, Ben, is technology is also changing how we apply standards. Remote monitoring and continuous data logging now give us more information than traditional periodic inspection. So in my view, I agree with Rahul. The strongest standard combined research, field experience, lesson learned from failures, and the appropriate use of technology and engineering judgment.
On the topic of research, I know it's very important to make sure that it's in line with what the needs are out in the field. So, in terms of bridging research with real world applications, how can universities like yours at Alaska-Anchorage, Raghu, and research programs at institutions like that best support the development of practical solutions that eventually influence those industry standards? Raghu, we can start with you because obviously you look at this from a university perspective, and then we'll get to George in Washington who can address how it's actually playing out in the field.
All right. Yeah. So from university, earlier universities, like when they do research, and I'm talking about like years ago, they work in silos where they don't really talk to the industry. But eventually, if you think about it, like all our students, they end up in industry most of the time. Only a few of them go to the graduate school and then they end up being an academic researcher or go into research and development. So now, as things evolve, where people can talk to each other more often with technology and everything, and an association like AMP brings different people together, we can learn from each other. So now, when we talk about technical mechanisms, theoretical stuff in the lab or in the class, now we're starting to think about like how this applies to real world situations. And then when we have industry experts coming to our classrooms and our students, when they go and do internships and then they come back with their ideas and then we have discussions going. So that helps a lot. Like I said, research has that advantage of like moving away from the standards a little bit. People are not going to question too much when we're doing research when we're not following standards. But again, the underlying theme is like get back to the standards and see how much we've deviated and whether it's working when we deviate or it's not working when we deviate, and then come back to the standards and then we keep changing that. I can tell from my personal experience the atmospheric corrosion. So when we have laboratory testing for cold conditions, we cannot really replicate that in the cold conditions with the existing standards. So when I do research with long-term field exposures and monitoring, and then I say, okay, so there is a gap there. There is a knowledge gap there. How are we going to bridge that gap? And one of the most important role that we do is we train students. So the students, obviously there's theory, the mechanisms, and they write exams and everything. But we also give them projects, the capstones, the design projects and stuff. And when they write their reports, we expect them to refer the standards in the industry so that they kind of get trained before they get out to the industry. It's not like they learn that when they are in the industry. They kind of know about these things. Maybe not all of them, but at least they know that there are standards and then they have to follow it when they get into the industry.
Washington, I'll go over to you. As someone that works fairly directly with operations and asset management, how important is the research that you're seeing in actually solving the challenges that you encounter out in the field?
Interesting, Ben. So research is extremely important because it helps us move from reacting to corrosion failures to predicting and preventing them. So, like for example, in the water industry, we manage aging pipelines, deteriorating coating, underperforming cathodic protection system, and interference from other electrical infrastructure. We also need to make decisions within limited maintenance budget. So research helps us to understand this problem and improve corrosion prediction, condition assessment, cathodic protection design, and risk-based maintenance. However, Ben, research must remain connected to real operational challenges. Asset managers need practical answers like what should we measure? How often should we measure it? What do we need the results and what do they mean? And when do we need to intervene? So the greatest value comes when researchers, asset owners, consultants, researchers like Raghu and field technicians come and work together. Research becomes more useful when it can be translated into practical guidance and eventually incorporated into industrial standards.
George, that same question to you. From an operational and asset management standpoint, how important is research to actually solving those challenges that you encounter?
Raghu and Washington, they have explained it clearly. So, from a field perspective, research is very, very important because it helps us understand the root cause of corrosion and inspection challenges and identify better solutions. However, laboratory results alone are not enough. The proposed solution should also be tested under actual operation or operating or construction conditions to confirm it is practical, reliable, and repeatable. So I would say research give us the technical basis, while the field validation give us a confidence to implement this eventually into the industrial standards.
I want to shift to a global discussion because the four of us today, we represent very different regions of the world. I'm in Houston, Texas, which is one of AMP's global headquarters. Raghu, you're in Anchorage, Alaska. George, you're in Saudi Arabia. Washington, you're in Melbourne, Australia. So you guys have traveled the world. You've worked across several world regions. Washington, I'll start with you. Are the corrosion challenges becoming more universal in that what you see in Australia is comparable to what you might see here in the United States? Or do local conditions still require significantly different approaches? What's that like from your standpoint?
Oh, that's an interesting question, Ben. So the short answer to that is corrosion mechanisms, they are universal, but the condition in which corrosion occurs, they are local. So steel corrodes through the same basic electrochemical processes whenever it is located. But however, the corrosion rate, the risk associated, the most appropriate control methods required can vary significantly between regions. From my experience across Africa, the Middle East, and Australia, I've seen major differences in climate, soil condition, water chemistry, like construction practices, and maintenance capabilities. In parts of the Middle East, for example, Dubai, and in Saudi Arabia, where Raghu is based, high temperatures, saline conditions, and very dry soils can create particular challenges. The behavior of the soil can also challenge significantly when it becomes wet due to rainfall, irrigation, or groundwater movement. Then if you go to Africa, for example, environmental conditions vary widely. The practical solution may also be influenced by access to monitoring equipment, availability of materials, and maintenance resources. Now, if you move to a country like Australia here, we have significant variation in soil resistivity. If you go up north there, it's quite dry. If you come down south here in Melbourne, it's wet and generally it's tropical. The practical solution also may be influenced by the monitoring system that is being used. We are also managing, for example, here we are also managing aging buried infrastructure and increasing interaction with DC traction and trams. We have a lot of trains here in Melbourne, and we have other cathodic protection systems also that influence the CP system. So these local conditions directly affect corrosion rates, the coating performance, and also how cathodic protection is distributed. So therefore, a global standard should provide the overall technical framework, but the engineering solution must be based on local environment, asset condition, and operational risk. So applying the exact solution everywhere without understanding the site conditions can result in adequate protection. So, and also excessive protection or unnecessary costs. So when you're applying the standards across multiple regions, you need to understand and apply engineering judgment. So that's my understanding to say, yes, corrosion mechanism is universal, but the condition in which they are they are just local.
All right, turning our attention to the next generation of standards, which I know at universities like Alaska-Anchorage are always in consideration. Raghu, what are some of the emerging technologies or industry challenges that you think deserve greater attention from the standards community?
The standards community, the industry is growing. And like I said before, the new technology is where we're getting new sensors, the new ways to monitor things remotely. The biggest pushes, like now we got a lot of data where the computing has become a lot more easier in terms of processing the data. So the artificial intelligence or machine learning that are becoming increasingly important. So now we have tools in which you can actually predict corrosion, identify patterns. You can actually prioritize inspections and stuff from a human perspective to a machine learning perspective. That's a huge shift. And I really hope the standard committees give proper attention to these changes so that like we can incorporate those things and not still left behind. And the other thing I would really like to see is the climate resilience. Things change. Washington was talking about it. He lives in Australia, which is a country and a continent, and most places also kind of like operate like a microcontinent. So the climates change a lot. I moved from Hawaii to Alaska, so there's two different, even though we're in the same country, completely different perspectives. And Alaska is being such a big state, things change as we move to different geographical locations. So that's the thing. The kind of like tying back to your previous question, the underlying scientific principles needs to remain global because you just can't change that. I know Washington put it together very well, but when you apply it, it needs to be local. You need to take care of the regional data, the environmental classifications, the variability in geographical locations, the engineering judgment, like depending on which continent or which country you're from, like how the judgment varies, the availability of tools. So you have to apply that locally. You cannot just keep on creating the same versions of the standards for different regions. So keep the standards global and the applications local.
With these new standards, it's one thing to simply apply them and use them in the field. It's another to actively participate in shaping them, both for the present and the future. Washington, why is it so important for the next generation to get actively involved and not just applying the standards, but shaping them on an ongoing basis?
Oh, yes, that's an interesting question, Ben. So it is important because the next generation will manage infrastructure under conditions that may be very different from those considered when many existing standards were developed. They'll face aging assets, changing environmental conditions, new material, increased electrification, and more complex interference risks. They also use technologies that were not widely available when many current requirements were written. If young professionals only apply existing standards without participating in their own development, those standards may gradually become disconnected from emerging industry challenges. So participation also helps young professionals understand why particular requirements exist. It teaches them how to assess technical evidence, learn from failures, and consider different industrial perspectives. At the same time, the next generation should also not disregard the knowledge contained in existing standards. Those standards represent decades of research, operational experience, and lesson learned. The real opportunity is to combine that established knowledge with the new research, technology, and the ideas that has been developed already. So experienced professionals also have a responsibility to mentor young engineers and technicians and create opportunities for them to participate in technical communities, in research, and training them and developing new standards. So it is very important that young guys, they participate in developing of standards because the industry is changing and it's dynamic as well, Ben.
All right, since we're talking about the future, let's look ahead to the next 5 years or so. What's the one change that you'd most like to see in how our industry develops, shares, or applies its corrosion knowledge? Washington, we can start with you.
Yes, so over the next 5 years, I would like to see a much stronger and faster connection between field experience, research, and standard development. Our industry connects valuable information through inspection, cathodic protection, monitoring, failure investigation, long-term asset performance data. But however, much of this knowledge remains within individual organizations. If we share field data, case studies, and lessons learned more effectively, we can improve our standards, we can avoid repeating the same failures, and we make better risk-based decisions. I would also like technology knowledge and specialist training to become more accessible to professionals in developing countries like Africa, the Far East as well. So, and one thing is, corrosion is a global problem, Ben, but access to training, technical resources, and modern monitoring technology is not equal. So it would be good if knowledge is shared and resources also are shared to developing countries. So that's exactly what I expect to see or what I wish to see in the next 5 years.
Raghu, the same question to you.
So I understand to develop standards takes time. And the most important part in developing standards is like bringing people from these different backgrounds together And I really like to see a much faster pace at which the standards are being developed. I know the slower pace is because like the opportunities to bring in the different people from different sectors together was a challenge before. Pre-COVID, everybody is in Teams or Zoom, so you don't have to wait for this in-person meeting. So now there's an opportunity to bring all of these different people together at a much faster pace or at a much faster frequency. So I really hope in the next 5 years, like from start to finish, the standards go a little faster than what it used to be before. And then with all these technologies, like I hope that's where we're heading towards. And associations like AMP and other professional associations play a very big, important role in bringing these folks together.
Gentlemen, thank you so much for the time. For anyone watching or listening that might want to learn more from your organization or company or get in touch with you, what's the best way that they can do that? Feel free to plug whatever you would like to plug. Raghu, we can start with you.
I mean, we're on the internet. Everybody is on the internet. You can find people. Like I said before, like it's easy to reach out to people. I know we have Washington joining us from Australia. It's probably like midnight over there. And like I'm here in Alaska, which is like a little early in the morning. Ben is in the middle of the day in Houston. So yeah, internet can bring people together faster. So please reach out so we can bring this thing together.
In Washington, I'm assuming LinkedIn is an option. Anything else you'd like to plug to our audience as far as getting in touch with you and learning more about what you all are doing?
Oh, thanks, Ben. It has been a privilege to participate in this discussion. Yes, LinkedIn is the best location to CV and to get in contact. We are now a global village. And yes, you can find me on LinkedIn, Washington Nyoni, the AMP Ambassador for 2026. And my main message is that corrosion principle may be universal, but every asset must be assessed with its local environment and operational conditions. And thank you so much, Ben, for having me.
And with that, I think we're done with today's standards episode. I want to thank our guest again for taking part, as well as all of you out there watching and listening. And if you want more resources from us here at AMP before our next episode in this series, just search for AMP at your podcast home or social media outlet of choice, or simply go to amp.org, ampp.org, where we've got a special page for our 2026 AMP Ambassadors, as well as a page that's being continually updated with all of our 5th anniversary content. Have a great day.